Hi everybody, it's nice to see you here. I have a great honor and pleasure to speak at this conference for the second time. So my name is Przemek. I will introduce myself in brief, I hope. I'm currently working as a senior systems engineer, but basically as a hybrid systems and software engineer at Applause. I do a lot with code itself, with deployment and CI there. Some of you might know me from the really cool software house named Toke. Be sure to check out their stand somewhere at the corridor. And apart from that, I'm a huge guitar geek. I play this instrument a lot and I'm a huge fan of it. Also some social media related stuff about me. You can find me on Twitter, GitHub, Facebook as well, but it's IT conference, so I've rejected this stuff. A little thing about Applause itself. You might know us by our previous name, UTest. It's a leader of in-while testing. We are app quality company. We have offices all around the globe, starting with headquarters in Boston. But we also have offices in San Francisco Bay Area, in Warsaw, Seattle, Berlin, and more. And make sure to pay us a visit at applause.com and check out our products. Really cool stuff. So going to the main subject of today's talk, we will try to think how to Dockerize running application and run it in production. Well, basically, to clarify, there is not any precise answer for that, but my idea is to give you some hints and show you some pitfalls that I've personally encountered at my journey on Dockerizing apps. So I believe I can give you a good bag of tips on how to do it. And the first thing is, when you consider Dockerizing an app itself, is whether to put all your stuff into a single container like this, or maybe to split it into several Docker containers itself. So let's consider this first approach. We will, for this presentation, I would like to stick to the web application example. I believe that it's most common setup for you as well. So most probably you will have some database, relational DB for persistence. Postgres is really cool in doing that. But you will have some, of course, HTTP server, some web application framework on which you develop your application. I've chosen Play because they have the most fancy logo. So if you put all this stuff in a single container, well, this is really a tempting idea, because imagine that you want to deliver your app to your customer. You only have to ship a Docker container, a single one, having just all this stuff, all your web application bundled together. So why won't we actually do it? Well, apparently we will end up with Dockerfile looking like this. It's really crazy stuff happening there. I've commented installing dependencies because, you know, apt-get install and huge list and pip install and I don't know, maybe even some else stuff happening there. It's lots of things to omit here. So let's focus on the CMD. There's lots of things happening here. It's not easy to read this stuff, even if you are a Bash geek. There's lots of things happening. See, Postgres, Elasticsearch, very hipsterish, and it needs to be here. Also, there's a supervisor as a process manager, so lots of stuff happening here. And in your Docker container, you will also have an isolated process pool. So everything is okay with that. Docker can handle multiple processes. And please note one thing, that there's no technical reason why you should really limit yourself to have only one process per container. So there's no technical reason why you should go for separating everything in separate container. But, however, and there's a big however, you need to do it wisely. If you've tried to do something like this, then I'm louder a bit, I think. So if you've tried something like this, that from Ubuntu image, you install your dependencies and run all this crazy stack in a single shell script, you've most probably failed the test. So why? Well, this is really cool thing to learn, because your start SH would be the very first process that will spawn other processes. So will it behave properly? Well, if we go to our knowledge from the operating systems concept from university or from Coursera, there's lots of resources to learn about operating systems right now, we most probably will recognize something as init process. And init process is a really special thing because it has an extra responsibility. And this responsibility is that it inherits all orphaned child processes and takes them and cleans up after they are done. So my question is the start SH ready to serve as an init process? Would it be able to spawn many other processes and then tidy up it? Well, Ubuntu itself has its own init system, which is called Upstart right now. So this is something like that Ubuntu has not been designed for being run inside of a container. So basically, what can happen? We can end up having multiple zombie processes. And why it's considered as a wrong thing and why I am considering this stuff as a pitfall. So keep in mind this thing, this actually a quotation, so I will try to read it. As long as a zombie process is not removed from a system, so from your Docker container, it will then consume a slot in the kernel process table, and if this table fills, it will not be possible to create further processes. Okay, so imagine that happening sometime in production, late at night. If you need to fire up several processes in a single container, you will need to do it wisely. In our case, if we end up with something like this, with such a situation, the only thing that we can do about this is restart our Docker container. So how many restarts will be needed until we will find out this? Well, so this is already solved. There are something like wiser images for handling multiple processes, which are cool, which are based on Ubuntu. And Fusion-based image is one of those, but there are also cool process manager which can handle that. So make sure that you use something wiser when you're stepping inside of production environment. And so as an opposite, right now let's consider having multiple processes and separate all these components into different containers. Of course, we will need to glue them somehow, so we can either use Docker linking containers, or we can just glue them with environment variables. For instance, this PostgreSQL database can be hosted on Amazon, and our Docker container would take simply environment variable. So this is really looks cool, right? Looks really production ready, robust. And imagine that right now I am going to upgrade this web application running on Play Framework, because you can notice the old Play Framework logo. I don't know if you are familiar and you like Play Framework. I like their website, their layout, their logo, so I've chosen this thing. So I am upgrading my web application right now, at the moment. And what I do, I just spin another container in this place. And imagine doing this in our former setup. In order to upgrade my Docker container, I would need to rebuild my whole container image. Well, Docker, of course, uses caching, so this rebuilding will be faster, but here I only have to substitute one single component. So, and what I can do is I can also achieve no downtime, because having several containers, I can substitute them one by one. So imagine happening that while having a single container, nearly impossible. So we of course can go to the pitfall number 2, because I can see environment variable here, and environment variables are something that I really like to talk about. Pitfall number 2 is having way too much in your config files. So you may ask me why I even consider this stuff as a pitfall. Well, especially in the world of Java, all I can say about config file, well, the things that I've mostly seen in my life was team of sysadmins polishing huge XML files, something like that, basically. So this is not so agile-ant container ready, and how to get out of this a little bit. Let's maybe draft a simple conclusion on why I consider this stuff as a pitfall. So since you have built your container with XML configuration file, it then became immutable. So as you know about Docker, you can basically, container can write multiple things, but all the changes that processes running inside container will make will disappear when container will be killed. So if you are handling many things in configuration file, you'll have to rebuild those images. So in order to change that XML configuration file, something really stupid like, I don't know, parameter like WebConcurrency or something like that, you need to rebuild the container image. Well, as I've mentioned before, Docker has caching, so it will be really fast, but you have to do additional tasks, rebuild container image, and of course, redeploy that container to all your environments. So keep in mind that environment variables are just passed to the container at the start with within Docker run command. So it's really simple, right? And let me just introduce my conclusion here. So the more config parameters you will keep in the environment variable, the less containers you will have to build and eventually deploy. So, but what can be really put into environment variable? Obviously strings, integers, some stupid parameters. Perhaps we can put something like this into environment variable. And it seems really cool. Imagine web application and substituting a old SSL certificate. Why you have to put it into a file, whereas you can just keep it in environment variable. It will work, trust me, and it works right now, at this time. So it's a really cool thing to know. And if there is something you could not put there, there's cool things called template. So let me ask you a question. Why won't we actually create a template of our configuration which can be dynamically rendered before container is being run, and the rendering will be based on all environment variables that will be provided? So you will, well, there are several templating languages. Personally, I mostly do with Jinja because I mostly program in Python, but also there's cool ERB and my favorite play framework, the HTML templating language in Scala. You can basically use everything, then you can render based on environment variables. So it's really simple, because when you try to think about it, if you would like to change some parameter like, I don't know, web concurrency, which is hidden inside of Nginx configuration, why you won't just run the same container which already has been deployed to your environment, but with changed web concurrency parameter? So it's really something worth doing. And back to the Dockerizing itself, how to Dockerize an application? Once again, Docker itself, as you know, is an isolated process pool. It's the most canonical definition. So one thing you have to do is to actually discover what actual processes and tasks are running inside of your application. I'm sticking now to the example of web application. Imagine that these three processes are something that I need to fire up on my production server. So what I have here, I have just a free web workers. For those not familiar with Python environment, this is just the WSGI server that takes HTTP requests, parses them somehow, gives them to Django, and does some crazy action inside. I also have two processes for running background tasks. Celery is distributed task queue in Python, but you can think of any other language example. My question is, can you release your product from a single code base? Because if so, then most probably you will end up building only one image from which you can spawn different processes and actually spawn the same processes that are already running on your production. So, for instance, in my case, from these things that I have here on my remote server, I would like to build a Docker image, let's name it like here, applause my app. all I do here is I do a Docker run. I run processes from a single container, but run different processes in that environment. And that's what Docker is all about. I also pass some environment variables to my Docker run, so that, and as I've talked before, this WebConcurrency parameters, I will have this stuff covered in the template, so there's a really cool thing about having it right over here. So imagine right now at my production stack, because I have all the things separated from each other, I can simply substitute this WebConcurrency parameter or request timeout parameter without redeploying and doing all this stuff. So this is the real Docker magic that is happening here. Well, if we go to the more complex setup than a web application, and if you cannot really find and you don't know what processes are running on your servers, I will strongly recommend this stuff called Microservices. There are lots of talks already here about microservices. But seriously, because you may consider it as a joke, apparently maybe it's not, no idea. So maybe you need to rethink, is any architectural change really needed? Because all Dockerizing is about discovering the processes that needs to be run somewhere. So think about it, if it's really needed, like here. And if we go to running Docker in production, well, we can prepare our production environment simply like this. We can take several Ubuntu hosts and install Docker there, and will it work? Well, please say goodbye to such solutions, because most probably you will end up configuring your own hybrid of deployment framework and infrastructure management tool, in which you will have to cover basic tasks that has been done for you, like high availability, config store, log collection, or distributing environment variables across all this Ubuntu cluster members. You need to take something wiser, and the selection of solutions is pretty impressive. There is really wide selection of tools possible here. So let me just introduce in brief that a couple of weeks or right now months ago, Amazon Web Services allows you to run Docker containers, but with a high-level approach. So you do not configure anything with your EC2 host. You just deploy containers and ask Amazon to be running somewhere over Ireland or US or Singapore. They have also computation power in Singapore. You can also deploy Docker containers to Heroku. So it's really cool, because Heroku were actually pioneers in LXC containers. So it's really cool that you can omit all those build packs and Heroku's internal deployment mechanism. You can just push your Docker containers to Heroku. So these two solutions, Amazon Web Services and Heroku, are something that is running in cloud over there in America or Singapore. So if you would like to have something on-premise, hosted on your own, you can go for either Deis, which keeps Heroku workflow but acts as a platform as a service. The same thing does the OpenShift, but it's purely by Red Hat, of course, but it's purely focused on having already made Docker containers. So keep in mind the cool chorus. By the way, I am describing these things in real brief, because if I will try to say something more about it, we will end up most probably missing our today's party, which is starting at okay, 7:30. Okay, so there are also cool, more complex projects called Kubernetes and Mesos. If you want to just make a picture of this slide and get familiar with several things, because all of these technologies are under heavy development, are real exciting. So there's lots of things to check out, especially the CoreOS, because it's an operating system purely focused on deploying Docker containers. So you have no package manager there. All you do is run Docker containers on this operating system, and it has built-in clustering and a perfect config store called etcd for storing environment variables, for instance, and distributing them to all the cluster members. And it's done for you. So having a setup with Ubuntu Docker and the blue screen of that, I think, oh no. Okay, so this is doable. And we at the PLOS we've covered that, but it's a lot of things to think about, which already has been done. So keep in mind these building blocks from which you can construct your production environment. I've also promised in agenda to talk about continuous integrations here. So there are really two important things to cover here. And these things are tagging and registry. So Docker tags is something that is not so kindly mentioned in all those Docker tutorials that you will find on the web. So first of all, think about a Docker container as some kind of frozen repository snapshot, but which is basically running an application. So what Docker tags gives you, well, first thing, for everybody who do not know anything about Docker tags, each image that you build can be tagged with multiple tags, and basically think of it like as a Git tag. It's something like this. You can tag your image as stable, as prod, as release 1st July, or something like that. You can tag images as you want. Tags can be pushed to remote Docker registry, just like images. I will talk about Docker registry later on, so stay tuned. But you may ask me what to tag and when and how to incorporate this Docker stuff into your daily work. So I bet that most of you heard about something which is called the Git flow, right? Something really recognized. So if you have your Git flow, you work on several branches, it will be a question. If your workflow will look like this, which points from here are deployable units, something that you would like to deploy or run eventually? Because otherwise there is no sense of building Docker image at all. So for instance, I can imagine that in such a workflow, I would like to build a Docker image from each commit of a master branch, and this is our candidate to be deployed on the production. However, I can build from each commit hash a separate Docker image and tag the latest one, Docker tag this image as my release candidate. So think of it, how to incorporate Docker inside of your daily workflow, because if you have such a cool designed Git workflow, it's almost already done for you. But getting back to the Docker registry and what basically this stuff is. So think of Docker registry as a release archive. This is absolutely a must if you would like to go with Docker on production. This is the service for all of you who do not know anything about Docker registry to host your Docker images. And this is something like hubdocker.com, but on-premise. So it's hosted on your own infrastructure, safely protected via corporate VPN and InfoSec policies. But the idea is just like GitHub or GitLab or all the stuff that you are using for hosting code. You build image once, tag it, push it to the remote registry. So every single developer in the company can look how does the repository write and eventually deploy that on production environment. The cool thing about this Docker registry that running this stuff do not need to ask some sysops guys or systems administrator, because it is super easy to set up and maintain. It's basically distributed as a Docker container, and it can use Amazon S3 bucket as a storage for your Docker images. So you do not have to worry about having server with proper disk space. You can imagine that Docker images are quite heavy things that can have several hundreds of of megabytes or even up to 1-2 gig. But also the cool advice here is that Docker Registry, I don't know why I didn't put it on slide, but stay tuned, because Docker Registry has a REST API. Okay. So my good hint is that in front of your Docker Registry, you can put some HTTP basic authentication to, for instance, prevent some developers from pushing certain tags. It will basically, and we personally use it at Applause, because we do not allow developers to tag their images as prod, because prod is an image which is ready to be deployed, which passed security tests, passed all the QA. So we do not allow developers doing that. Only blessed sysops person can do that. And this is how we deal with some InfoSec policies, SOC 2, especially in corporate environments. It's quite important. So you can set up an HTTP server in front of Docker Registry and control it somehow. So this is a really cool thing to know. And let's think about Jenkins. We use Jenkins religiously as our CI server. So what can Jenkins do here for you? Well, Jenkins, of course, will build all this, builds, I hope, builds all the commits that I've shown you on this Git workflow. But what Jenkins can do is that it can run a test suite inside of a Docker container. So think about it. You do not really need to provision any server, because all you need is something as light as CoreOS or anything on which you have Docker. You can run your test suite inside of a Docker container and delete it afterwards. So it will be really like fast that you can spawn several Docker servers to handle your build nodes. Of course, Jenkins can, after successfully test or pass, it can build image from a certain commit. And all the things I will cover on this slide has been basically, do not require any shell magic that we all do love. They simply has been already implemented by great plugins for Jenkins. So you just install Jenkins plugin and you can have, for instance, Docker images built once tests have passed. So Jenkins can, of course, tag an image, like, for instance, tag certain application image as your release candidate or stable build from 1st of July or something like that. Jenkins can afterwards push that tag to the remote Docker registry. So all the developers in a company can simply Docker pull that image and see how the new revision of the software will work. So, of course, if you are extremely courageous, you can deploy containers to certain environment automatically with Jenkins. If you have a perfect workflow, you can omit database schema migration problems. It's really something worth checking out. Imagine that Jenkins is automatically pushing your release candidates to testing environment. Extremely comfortable, isn't it? So I am totally aware that I've said a lot here, so let me just go through a short recap on what I've said. And basically, we've been talking a lot about splitting the application in a containers. So think, if you can release from a single code base, how many containers do you really need to deploy your application and have it running? Of course, try to export as much as you can into environment variables, because as you remember, the more you put into environment variable, the less images you will build. So for the win, dynamically rendered templates. This is really cool stuff, worth checking out, highly recommend for me. And keep in mind the zombie process pitfall. It is something that can really bite you someday, or most probably known Murphy's Law some night. And rethink whether some architectural change in your software is really needed. Perhaps you need to separate some pieces into something completely different and deploy it completely differently. Walk through your Git workflow, but now, after this presentation, keeping in mind your deployments, when you would like to deploy, and of course, where, because we've been also talking about where to deploy and where to not deploy. Go and set up a Docker registry for your team. It's really simple. It takes, I don't know, maybe 15 minutes of configuration. You're up and running. Use CI religiously because it's extremely comfortable. Just comfortable. Automate as much as you can. With CI is really possible and doable. And automate as much as you can since now, including your deployments. So I'm Przemek Hejman. Thanks a lot. It was a great pleasure to be here. Thank you for having me here.